DFS means distributed file system, where the data will be distributed across the multiple machines. Each machine will have a specific type of data. Each machine will have specific type of data. A very simple example is a shared drives. Like let's assume that shared drives. See, in our offices, the shared drives works such a way that they will give you one path for everyone. Okay, for everyone, let's assume that the path is, they'll say this is the path, okay, for the shared drive. They'll say slash data share. Let's assume that. Okay, let's assume that data share. So that path, right? That path is nothing but a DFS layer. And let me write one more time here. And it's, let's assume that this is the path they have given. So this path is like how you have to access. Control Shift R, I mean command window R, like how we have a window symbol, right? Window symbol R slash data share. Let's assume that they'll give like this. Okay, when you click on this, it will connect to specific machine, but here it's not connect, but that is such kind of thing is not there here, right? Yeah, so let's say they'll give like this. When I click on this, it will connect to a specific a layer where multiple computers are share the data, where multiple computers are share the data. They will be sharing multiple computers. Our colleague will be sharing the data. Okay, but if I want to access the data, I no need to log into a specific machine. Suppose I want to get the data from my friend, I no need to log in here. If I go here in this layer, the data will be available. I can get the data. If I go there, the data will be available. I can get the data, right? That's a kind of a shared drive, right? Even though multiple machines are connected underneath for the client, so I can able to see. Let's assume that he's my colleague A, he's my colleague B, he's colleague C, D, E. I'm able to see all these machines data in a single entry, in a single path. That is a distributed file system. That's a distributed file system. So let's take a simple example, real-time example. Yeah, it's not able to do because I need to be in the same network. I have to be in that network to get the shared drive. Okay, let's assume that let's take an HP company. HP, our HP Hewlett Packard, HP company, or you take a Dell company, whatever the company. So they will be having their sales in India. They'll be having their sales in Japan. They'll be having their sales in USA. They'll be having their sales in Canada. So there are different countries, different countries. They'll be having their. Suppose they want to know what was my sales in India, what was my sales in Canada, what was my sales in here. So they will not log into specific machine every time. They'll not log into India machine. They'll not log into Canada machine. They'll be having a distributed layer. They will be connected to one machine only. They'll connect to one layer. Then they will talk. They'll try to get the data from the different machines. They'll try to aggregate, understand it. Right? That's a shared drive. The best example is your. That's a DFS. The best example is your shared drive. Clear about the distributed cache or distributed file system? Are you guys clear about the distributed file system? Yep. So let's look at. So already I have a distributed file system. Then why should I have a Hadoop? Why should I have Hadoop distributed file system? Why should I have Hadoop distributed file system? Now we know how distributed file system works. Suppose if I want to put any data, Let's say I want to put the employee data go to specific machine. If you want to give the student data, it will go into specific machine. Projects, it will go into this machine. Suppose I want to put projects data, it will go into specific machine, right? So let's look at how Hadoop file system works. As we know that, as we discussed in the last class as well, Hadoop come up with two beautiful components. What are they? Hdfs and MapReduce, right? So let's talk about Hdfs. Let's talk about Hdfs. Already we have a distributed file system, then why should I have a Hdfs? So if you know, so now you know about DFS, let's try to understand about the Hdfs, then you will only tell that why we need that. Your HDFS follows this distributed system follows master slave architecture, where I have called a master node. There will be one machine called master node, and there will be so many slave nodes. There will be so many slave nodes. This each master node will be connected, each slave node will be connected to master, and we will be having one client. This master is called name node. Slaves are called data nodes. Slaves are called data nodes. Here also, when you connected multiple computers, when you connected multiple computers in the network, these guys also will follow a specific layer will be formed here. A HDFS layer will be formed here on top of all these computers. All these computers are connected, and this there will be a specific layer will be formed. This layer is nothing but HDFS. This layer is nothing but HDFS. This is client. This is client. Understand? Right? Now, how it is different from previous approach, normal distributed file system, how it is different from the previous approach. Let's assume that here I want to, let's say I have some data which is Amazon data, where I have data which is, let's assume that's 60 GB, 61 GB data, and my block, what is the block size here guys?
64 MB or 128 MB.
Or 128 MB. What is the replication here? 3,
3.
right? So now when I want to put this Amazon file, let's say this file name is Amazon. File name is amazon.txt. Amazon.txt. So now this file I want to put, into HDFS, not into normal distributed file system. I want to put into HDFS. So I'll be writing some command. The command is, anyway we'll be seeing the command very soon. The command is like Hadoop fs hyphen put, and I'll give the path of the Amazon file slash Amazon file dot txt to in HDFS slash data. slash data. Let's assume that. As soon as I execute this command, what will happen? My client, so client is nothing but where I'm executing this command. Okay, where I'm executing this command. It will what it will do? It will break this data into pieces. Why it will break into pieces? Why it will break into pieces, guys? How many pieces will come? Because the whole data will be divided into smaller blocks. The block size is 64 MB or 120 MB blocks are there, right? The whole data will be divided into blocks. Whole data will be divided into blocks. Block 1, block 2, block 3, and so on. How many blocks will come for 1 GB data?
16.
16 blocks will come. Very good. So my client, what it will do? It will take the first block. It will take the first block. My client will do, he'll take the first block. Then he'll go to a name node. He'll go to a name node. This cluster looks like our team manager and team members, right? This this architecture looks like a team manager and team members, right? The same way how our team works, the same way this approach works. Let me explain you the how it will work. So when I execute this command, it will take the block 1 and it will go to a name node. Name node is a master, and master knows about all the child nodes or all the slave nodes. Your master knows about who is free, who is working current work task, who has the space, and all the information known by your master. So that's how our manager knows who are all been on vacation, who are doing what work, and who are all which type of work they can do, with the development work or testing work, what type of work they can do, what is their expertise. All the information will be maintained by our manager, right? The same way, the same way here also the name node will maintain all the information in the form of metadata. That will be in the form of metadata. Then what will happen? Your manager, your name node will try to look for who is free. Will try to look for who is free. Okay. Then he will once he find the few guys are free. Okay. Then your client will go to name node saying that, hey master, I brought the something for you, which is a file is Amazon. File is Amazon. I brought the block 1. Tell me where and all I want to store. Because my block size is 64 MB, I need 3 missions. Give me 3 missions. Then your manager or your master will try to look for the who are all free. Then he will pick 3 missions. So he will pick 3 missions by following the block replacement policy. We will talk about the block replacement policy in the next coming classes. And he will look for the block replacement policy, and he will follow that policy, and he will give 3 missions. Let's assume that he has given 3, 4, 5 missions. He has given 3, 4, 5 missions. He will give those missions in the ascending order. He will give those missions in the ascending order. So ascending order based on what? So these missions will have IP address. Is that based on the IP address? No. Who are all near to the client? Let's assume that the client is here. Who are all near to the client? That come first. Who are all? So based on the network distance from the client, it will sort the value. It will sort the IP addresses. Then it will give to a client, right? So block one, I have given 3, 4, 5 missions. What your client will do? Your client will connect to third mission. Your client will connect to mission 3. Your client will connect to machine 3, and anyway the machine 3 and machine 4 has a connection. Then they'll start passing the data. The 64 MB block, they cannot send through a network at a time, so they'll break into small packets. The data will be break into small packets. The packets will be transferred to machine 3, then it will go to machine 4, the same packet, then it will go to machine 5. It means your client is connecting to only one machine, and internally the communication will happen. This machine will transfer the data to this machine transfer the data to the other machine. So these machines will be having a information about other machines. Now the block 1 is stored in machine 3, machine 4, machine 5, and it will next also block 2 will happen the same. So block 2, it can choose the same machine or it can choose the different machine. Let's assume that this time 135. So machine block 3, it is stored 1 2 3. Block 4, it is stored, it is, let's assume that it is stored in 2 3 5, and so on. So and so on. So all, it will repeat all the blocks, all the blocks. This information is nothing but a metadata. This information is called metadata. Who will maintain this information? This information will be maintained by name node. This information maintained by whom? Name node. This information maintained by whom? Name node. So as soon as they receive a block, right, they'll inform to manager, sir, I have received a block, I have received a block. That's how they'll make this kind of entry. This is called file to block mapping. File to block mapping. Okay. This information called block to data node mapping. This is called file to block. This is called block to data node mapping. Who will maintain this information? Anisha, who will maintain this information? Yep. This information will be there with the name node. It will be there in the name node RAM memory, as well as it will be there in the name node hard disk also. Okay. So these data nodes will be keep sending a heartbeat every 3 seconds saying that we are alive. These data nodes will be keep sending a data heartbeat to this machine saying that we are alive, we are alive, we connected, we are alive, we connected, we are alive. Every 3 seconds these guys will be sending a heartbeat to name node. So if you see here, your master is saving namespace. Namespace is nothing but address where the file is like C drive, C colon slash, entertainment slash, movie slash, we will, the path is there, right? Your name node maintains that kind of path, that is called namespace. So where is Amazon file is then Hdfs now? The Amazon file is there slash data slash Amazon dot txt. This is the path, right? It's then Hdfs. This is the path, right? This is called namespace. This is called namespace. Who maintains this space? Your name node. That's why we are calling a master as a name node. They maintain the namespace. They maintain the path. That's why we are calling name node, because it is maintain the namespaces. It maintains the namespaces. That's why we call as a name node. Below machines are maintaining the date blocks. Below machines are maintaining the blocks, small chunks. So data. So these machines are maintaining the data. These machines have a data. That's why these are called data nodes. Is your name node stored data? Sachin, is your name node stored the data?
No, it only
No.
stores metadata.
It only stores the metadata. It didn't store the actual data. That's why we'll call it as a name node. It stores only namespace. It will not store the it will not store the actual data. So now here, if you look at here, if you look at here, is that whole Amazon data is stored in single machine or multiple machines? The whole Amazon data is stored in a single machine or multiple machines?
Multiple machines.
The whole data is stored in multiple machines. How it is stored? In the form of small blocks, right? When I am processing the data, let's assume that I want to process the Amazon data now. So my data is distributed across the multiple machines. The same type of data has been distributed across the multiple machines. So let's assume that, so tomorrow, I'm getting only these colors, huh? I'm supposed to get multiple colors. Okay, so here, if you see here, I want to process block 1. So I'll process block 1 in machine 3. I want to process this data, right? So processing the data means applying a logic. Okay, so now I want to find out how many people have purchased mobiles, let's say. So to process that, I have to process all the blocks, right? If I'm processing Amazon file means I have to process all the blocks. So my block 1 will process in a machine 3, and block 2 machine 1, block 3 machine 2, block 1 is in 3 machine, block 2 is in machine 1, block 3 is in machine 3, block 4 in 5, and so on. So now what's happening? My data is getting processed parallelly. My data is getting processed parallelly. So if my data is get processed parallelly, I can achieve the time, right? Let's look at the first limitation. What is the first limitation? Cost, time, no data localization, no parallelism, automatic replica, and these things, right? So now I have a automatic replica is there. Now I have a automatic replica is there. Now I have a parallel processing is there. Now I have a parallel processing is there. So because I'm processing parallelly, I'll take less amount of time, right? So to process the data, wherever the data is there, let's assume that the data is then in machine 3. So I'm processing machine 3 only. I have data in machine 4. I'm processing machine 4. I have data in machine 5. I'm processing machine 5. What does it mean? Data localization. I have a data localization. I have a data localization. And because I'm processing parallelly, I have a less time. I have a less time because I'm processing data parallelly. I'm I'm processing it in a less time. And let's assume that while I'm processing block 4, the machine 5 is failed. Will my job will fail or it will launch another machine? Because I have a 2 more copies in 2 different machines. I can launch the same job in machine 3 or machine 2. That is called auto fault tolerant or speculative execution. What is it is called? Speculative execution. If while I'm processing data in one machine, if that machine goes down, my date my job will not fail. The job will try to look for the different machine where the data is available. There it will execute the data. That is called speculative execution or auto fault tolerant. I have auto fault tolerant. I have auto fault tolerant. The next one is cost. So Hadoop is open source. I need to buy a license. Is it Hadoop is open source and I need to buy a license? So Hadoop is open source. So no, I no need to pay to anyone. But you may ask, but we are not paying software, but you are buying so many hardware. Correct. But I'm buying the hardware which is a commodity hardware, which is a cheaper hardware. I no need to. go with a dedicated hardware. I can go and connect my laptop also, which I have, where I have a 16 GB RAM, 1 TB hard disk, and i7 is the processor. I can go and connect my laptop also in the cluster. Cheaper hardware. We can connect cheaper hardware. So because of that, so I can also reduce the cost. Everyone can offer, even small scale industries also can offer this. This is how the HDFS works. Any doubts, guys? Anisha, Harika, Kishore, Sachin, Shravani. Any doubts? Sachin, any doubts? Do you understand how HDFS works?
Yeah.
Kishore, Anisha, Anisha, are you there?
Yes, yes, I understand.
Any doubts? Kishore,
No, Viras, I'm with.
Shravani? Okay. So let's look at uh, some more detail. Let me open PPT. Yeah. Let's look at, guys, some more detail. Then we will move into the so is everyone able to see my screen? If anyone has any doubt, please raise. Okay. So what is big data? Big data. What is a big data? A huge amount of the data which cannot share, which cannot store and process using traditional approach in a given time or efficiently. That's the What is a big data? It's a huge amount of the data which cannot be stored and processed using a traditional approach in an efficient manner or in a given time. So that's called a big data. So how much huge? There is no there is no um, measurement for that. So whatever the data is not able, failed to process in traditional approach, that data we can call as a big data. And how the data is grown, if you take 80s, it was then kilobytes, then the data is grown. You guys very well known about it, how fast the data is growing, because of the users. There are so many users are increasing in the day by day. So that's why there are so much of data is getting emitted in the market. So variety of data, yesterday we have discussed about variety of data, and like structured data, semi-structured data, unstructured data, and your CSV files, Excel sheets, or database tables are the best example for the structured data. And there are some characteristics for the each data also. The characteristics are volume, velocity, variety, veracity, and value. Volume represent how much data you are dealing with. Data volume is increasing exponentially. Lot of data in being generated from the different sources like social media, new stock exchange market, sensors, right? 5 databases of the data is existing in the whole wide. And if you also observe, 90% of the data is generated last 3 years. Suppose if you take whole data is 100%, 90% of the data is generated last 3 years only. It means very recent. Means very recent. You can understand how fast the data is in generating, right? So the amount of the data, you can see that so many, Facebook and Walmart, there are so many sources where the data is coming. And velocity, yes, the data is being generating very fast. And how fast the data is getting generated, so that much fast we need to provide the analytics to understand the market, to understand the business strategies. So there are different sources from where the data is generating. So you can look at your satellite, you can sensors, you can look at your healthcare, or you can use social security, social media. There are so many places from where we are getting the data. And variety of data, we know that there are different type of data, and text and numerical or images, audio sequence, so there are different kind of data. And veracity, how good the data is, how trusted the worthy the data is, because we are talking in different social media here and there. I may get the data in the different format, but how good the data is, how can I believe the data is correct or not, right? That's the veracity. And value is the most important thing. Value is the most important thing to improve our business. Whatever the data we are processing, so that should be having some business value. If you don't have any value, the waste of the time and waste of the resources. And the other one is variability. Variability means just keep changing the data one state to another state. Suppose I'm handling today tables, tomorrow all of a sudden I got the text files. I should be able to handle, right? How important is this? So it's important to understand the business market, social security, law enforcement, improving healthcare, sports, no human disasters like healthcare or future predictions. So why we need to learn the big data? Because if you learn the big data, and the end of the day, because of the big data, end of the day we'll be doing a big analytics. We'll be getting the big results. If you have a big results, you'll be getting a big opportunities to improve your business. So, so what is the conclusion? Learn big data and earn big data. Earn big. So this is what the traditional approach. This is how the data processing in traditional approach, and we have seen it. What is the limitations? It is expensive and it's also scalable and time consuming system. Cost and time and expensive. And scalability also is one of the major problem. Scalability is one of the major problem. Okay. And difference between SQL and Hadoop. So before explaining this, I want to explain something on something interesting one. Yeah, let's assume that for time being, we are a Hadoop, we are a hotel manager or hotel not manager. We have our own hotel. We are the owners of the hotel. Okay, we are the owners of the hotel. Let's assume that we are providing a very good service, and it's a restaurant. Let's assume that it's a hotel and restaurant where we are maintaining very good no service, where we are providing very nice service. Okay, so let's assume that because of your service and because of the delicious breakfast, your hotel become a popular. Then when your hotel become popular, you thought that you want to improve the business, and you have increased your hotel size by doubling it. You are increase your hotel by doubling it. And so because so many people are coming visiting your hotel, so many people are having breakfast and they are getting very good service, and your hotel become worldwide famous. Okay, then what you thought, whenever becoming a popular, we thought to improve our business. Then you decided to double the size of the hotel. Then you decided to double the size of the hotel. You have double the size of the hotel. As soon as you double the size of the hotel, the day one you face a problem. What is the problem? Your hotel is full and everyone is started coming for breakfast. Where is your breakfast? You have a breakfast in a lobby somewhere, and you have elevators. You have elevators. Everyone has to come to here. Everyone has to come here for the breakfast. Correct? Let's look at in the previous screens. Let's look at in the previous screens. You have a breakfast here. Everyone is coming through elevators and they're having the breakfast, and they're going back, or they're coming to breakfast in the elevators, right? So when your hotel become a popular, you also increase the elevators with this very good speed elevators, but still the crowd is huge. The people are huge. There are so many people in the hotel. They're not able to come down. The elevators are not that much fast enough to clear your crowd. Even though you're providing a very nice breakfast, people are not able to have a breakfast. It's supposed to be start the breakfast by 8:30. You started by 8:30, but which is supposed to be complete by 10:30. Because of the crowd, you're still serving the hotel. I mean, the breakfast. You're still serving the breakfast till 1 o'clock, 2 o'clock. So what will happen? Then the people will get disappointed, and your service. I mean, you will get defamed, and the hotel will become the bad service. Like they say that it's a very bad service because of the everyone has to travel to breakfast in the lobby. If there are 10 floors, 20 floors, across the 20 floors I have to come because the hotel is full. Everyone has to come, and the people are file up at their hotel. I mean, your breakfast dining area, or at the each and every floor in the elevators. Correct? If we compare the same example with the real-time examples, let's look at here. Let's try to understand. What is your hotel is storage. Your hotel is storage, and your elevators are the network. Your elevators are the network. Your elevators are the network. The people are data, and your breakfast area is nothing but a data processing. This is how the real time looks. This is how the real time looks. This is how the real time looks. So what's happening? Because of the data is increased. Okay, let's look at. So this is how that existing system works. Let's look at here. The above story, whatever the story we have explained, is similar to the data storage and the data processing here. Data storage and data processing here. Let's look at, guys, on a bigger image. Your data will be in the different machines, and data, even though you have a 10 GB bandwidth of a data network bandwidth, but there is 1 TB data is traversing. There is 1 TB data is floating. Even though you have a better storage, better processing, the data has to move from this to other place, which is a costly operation. Which is costly operation. Understand? Because of this, what's happening? How even though we have a very good kitchen, and you are not able to provide the service, you are not able to clear the crowd. Clear the crowd. Here also happening the same thing. Even though you have a better processors, even though you have a better processors, you are not able to process the data in time, in a given time. Understand? This is how the existing system fails. Not failing in the sense it's taking so much of time. Then what Hadoop did, instead of Hadoop come up with a solution for the same. It's saying that instead of having a single processor in a single area, single dining area, instead of having a dining area in a single place, I will keep a small dining area in each floor. I'll keep a dining area in each floor. This side, each floor I'll keep a single dining area. Every day morning, the cooks will go to respective floors along with their recipe and their ingredients to prepare the breakfast. Then the people who are staying in which floor, the floor, respective floor, they no need to go anywhere. They can get serve the food into the respective floor itself. Which approach looks good? Which approach looks good, guys? Sachin, Shravani, which one looks good?
Obviously, the Hadoop one.
Because we are getting served the food at the same floor. I'm not wasting any time. I'm getting served at where I am. So the breakfast can start by 8:30, and it can be 8 o'clock or 7:30. It can be finished in the given time. right? So this is how the Hadoop different from SQL. So moving data is a costly operation. Moving data is costly operation. Let's compare with that. So this is how the new things, I mean your floors are nothing but each one computer in each one rack. This is a single rack and this is a single computers. Each floor is a computer in a Hadoop rack, and the moving data between floors is nothing but moving data between one rack to another rack for the processing the data. This is better moving your cook to, or moving your kitchen, moving your cook to each floor for providing the breakfast. I mean he'll cook the breakfast there and he'll provide the breakfast instead of getting all the people towards your processing, instead of getting all your people towards your processing area, which is costly operation, which will take so much of time. Understand guys how the Hadoop works? Hadoop works wherever the data is there, it will work there only. The data will not be moved. That's called data localization. That's called data localization. Understand guys? Understand? Now let's look at the differences between Hadoop and let's look at the difference between the Hadoop and SQL. Is everyone clear? I hope everyone clears about it. If you guys didn't clear, please let me know. I will explain one more time, then I'll go with the differences. Anisha, Harika, Kishore, Sachin, Stravani.
Fine, Viren. Understood.
Harika,
Clear, sir.
Anisha and Stravani.
Clear, sir.
Okay. So now let's look at the difference between Hadoop and SQL. SQL is SQL is schema on write. What is schema on write? Suppose you are moving data from one database to another database. I should know what is the table. Let's say you have employee table in a database A and you are moving the same data into database B. First you should know employee, what is the type of employee data as, what is the employee ID type, what is employee name type, what is employee salary type. I should know the schema of employee to write a data into other database. What does it mean? What does it mean? The data, while writing a data into RDBMS, we should know schema before. It is a schema on write. If data is not matched, let's assume that in a table employee ID is integer. Okay, let's assume that you have taken employee ID is the integer. But when you are writing into database B, you have assumed that database is a varchar. So can we write a data? No. It tells that it is data mismatching. Data is there is a mismatching. I cannot proceed. It will throw an error saying that data is mismatching. Write the proper schema properly. Understand guys? This is schema on write. Your SQL is schema on write. But when it comes to the Hadoop, it is schema on read. It never follows any schema while writing the data into HDFS. You can write any type of data HDFS. That's what we have said. You can write unstructured data, you can write a structured data, you can write your semi-structured data as well. It never no need to worry about what type of data I'm writing into in the machines or in HDFS. But while I'm processing, how I need to process? We should know, right? So if you know the data, then only you can process. If you don't know data, how will you write your logic? How will you process it? So that's why Hadoop is schema on read, not schema on write. That's the first difference. To understand what is the schema on read, how data will load in HDFS, the data will load in HDFS in the form of smaller blocks in the multiple computers, right? The data will load into HDFS the small blocks. Then how we will process the data? By writing some Java program, or by writing some Hive script, or by writing some pig script, or by writing some Python script, or some kind of script. Then how it will execute the script? The script will execute in all the machines. The script will execute in all the machines. Why it is executing all the machines? Because the data is there in all the machines. Because the data is there in all the machines, right? So let's understand the second difference. How the data loads in Hadoop, how the data loads in SQL, right? How the data will load in single one machine. In SQL, it is relational database. In SQL, the data is relational. One table is linked with another table is linked with another table. It's like a relational. It's a mapped. It's a logical forms, right? Each one will be having a related. That's why we call the RDBMS, Relational Database Management System. Each table will have some relation with other table, right? But when it comes to Hadoop, how the data will store the small chunks in the small blocks in multiple machines, and each block will be processed by individually. Let's take an example where we are storing some Twitter data, into Hadoop. You have 1,000 servers. And we are loading some Twitter data into Hadoop. How the Twitter data will load? Some part of the data will go in submission, some part of the data will submission, some part of the data will go in, because it's a block, right? It will go distributed manner, right? So let's assume that you have loaded the 60 that whole data into 60 servers. So 60 servers means the whole data across the 60 machines are there, and it's also replication factor also 3. By default, the replication factor is 3. And all that information maintained by whom? Name node. All the metadata information will be maintained by whom? Name node. Now, so how the data will get processed now? Let's look at the third difference. Now you have loaded the data. Now let's look at the third difference. I'm searching for a keyword called unhappy. Okay, I want to find out how many people are using, how many people are saying unhappy with it. There are some Twitter tweet. Let's assume that today we are launched new dimensions in India, new dimension cache in India, right? So how many people are happy or how many people are unhappy with that decision? Okay, now I want to do that analysis. So when I do this logic, I want to search for the unhappy keyword. So what I need to write some Java code. The Java code I need to execute in all the machines, correct? So let's assume that I am executing all the machines. I got from this machine some result came. So while it is processing, let's assume that one of the server is failed. You guys can see here, one of the server is failed. Will my job will fail or success? While I'm processing the data, one of the machine is failed. Will my job will execute, successful, or it will fail? Anisha, Kishore, Sachin.
Even though the server where data is available, it might succeed over them.
Yeah, Sachin.
I think it should succeed because we have same data replicated on different machines.
Yes. So Hadoop says that I will not fail because I have data replicate another machine. I will success. But what SQL says? The question is that should I hold up the entire response to the user, or because I do not have entire data set in the process? The answer to this question is that is the primary difference between your SQL and Hadoop. So Hadoop says that no, I will not hands up. I will just I will not say it's a fail. I will process the data because I have a duplicated data in another machine. But when it comes to SQL, SQL, while processing the data, one of the machines fail. SQL says that the job is failed because it needs. SQL says, yes, I need complete consistency across all the nodes before we release any anything to the user, which is called two-phase commit. Which is called two-phase commit. Both of approaches. See, Hadoop says yes, I can do that, and SQL says no, I cannot do that. So it doesn't mean that SQL is not a good approach. It doesn't mean that Hadoop is a very good approach. But both has their own pros and cons. How? Let's look at, suppose both of the approaches that their advantages based on their type of data you are as being processed. So let's assume that, so you are doing some transactional things here. So something happened wrong while you are doing a transaction. You should have an option to roll back, right? You should have an option to roll back. But in when it comes to Hadoop, I don't have a rollback because I have another option where I can process the data from other place. There may be some places where you need a rollback. So that kind of approaches SQL is better. The other kind of approaches Hadoop is better. Understand, guys? Understand? These are the differences between SQL and Hadoop, and that is how Hadoop works. So we'll see in more detail in the next class. Any doubt, please stay back and ask me, or others can leave for the day.